more rational functions. Again, we're going to start by factoring. And so we can see where our roots are, where our asymptotes are, and if we have any removable discontinuities. So for this one, on top, I can factor out as 2. Ooh, and then I have a difference of squares. On the bottom, two numbers that multiplied in 6 and add to -7 are x minus 6 and x minus 1. I'm going to keep going with factoring there. Get that difference of squares factored down. So I can do most of this without a calculator. You are not required to do that on the exam. But I just want to show you how fast you can be here. Here, I know my removable discontinuity is going to be at x equals 1 from what cancels here. And we'll look back at that on the calculator. My vertical asymptote is going to be at x equals 6. And my X-Intercept is going to be at x equals 1. So we've answered the majority of our questions that were asked for this problem already. The other thing that we know, the piece that we haven't used yet, is an important piece. It's our leading coefficient here. Since we have the same degree on top and bottom, we use the leading coefficients to get our horizontal asymptote. Since it's the same degree. And that's the majority of the information we need in order to answer all of these questions. Again, you can absolutely graph it in your calculator and lean on your graph, but you know how to get all these pieces of information, and you can be pretty quick if you're answering a multiple choice question just about asymptotes or discontinuities. Okay, let's go in order though. X-intercept. Our only X-intercept here is at x equals 1. We'll get our Y-intercepts when we put this in our calculator. I'm just going to leave that a blank for now. We have a removable discontinuity. It's at x equals, positive 1. Oh, I need a -1 there with my X-intercept. Sorry about that. Back here, when I set x plus 1 equal to 0, I should get -1. You guys are probably yelling at me through the computer. Okay, so my removable discontinuity is at 1, and we can find that y value using our calculator in a minute. Asymptote, vertical asymptote, there's just 1. Horizontal asymptote, just 1. And domain and range. For domain, we are going to exclude our x value from our removable discontinuity and our vertical asymptote. Those are not points on our graph. So we are going to exclude +1 and +6. For range, we're going to exclude our horizontal asymptote as long as it's not crossed, and the y value of our removable discontinuity. So once we get that on our calculator, we can fill in the range. Let's graph this and find those points. So in order to tackle this one, I'm going to put in 2 different equations into my calculator. I'm going to put I'm going to put in the original. And then I'm going to put it in the factored version with the x minus 1's canceled. that will give me a value at x equals 1 so that I can see the y value of my removable discontinuity. So I'm going to put in that factored and canceled form. The graphs should overlay everywhere but there. So that's another way to check your factoring. If I factored wrong, the graph isn't going to just write right over itself. All right, looking good. Little calculator trick, if you hit trace right here, it'll pop up on the y-intercept. So our y-intercept is 0, negative 1/3. And again, to find the y-coordinate of our removable discontinuity, we're going to go to our table. We should have an error at 6, where we have that asymptote. And we do for both. That asymptote is a part of both of those graphs. The thing that's different here, and it is because we made it this way, we asked the calculator to give us the factored and canceled version. So the y-coordinate of our whole is negative 4/5. And we need that for our range. Does not look like we cross our horizontal asymptote. So we're going to go negative infinity to negative 4/5. Negative 4/5 to 2. 2 to infinity. All right, one more. And since we have done a bottom-heavy fraction and a fraction with the same degree, you should have expected to see a top-heavy. And this guy is a top-heavy fraction. We can factor this, but nothing cancels. So it's good to factor for a couple reasons. One, that gives us our x-intercepts. The top of your function here, the top of your fraction gives you your x-intercepts. So I expect this graph to cross the x-axis at 4, 0 and negative 3, 0. Again, this is top-heavy, so we're going to have an oblique asymptote. Our vertical asymptote comes from the denominator. It's going to be at x equals negative 1. And the way we find that oblique asymptote is to take our numerator and synthetically divide by our vertical asymptote. So I'm going to use this negative 1. I'm just going to do synthetic division on the top there. So it's 1x squared, negative 1x, negative 12. When we're doing synthetic division, we bring down the 1, bring down that leading coefficient, and then multiply here. Negative 1 times 1 is negative 1. Add vertically. Negative 1 plus negative 1 is negative 2. And you'll remember we don't care about the remainder. So my oblique asymptote here is y equals x minus 2. You can graph all that together to check. Clear out my last problem. So I have x squared minus x minus 12 over x plus 1. I'm going to go ahead and put my oblique asymptote in as well so I can see how it fits and check my work. So the red up here is my rational function, and the blue is my oblique asymptote, and that looks pretty good. Because of the way this function works, it is going up forever and down forever. I like these. I know that my range is all real. My domain, here's my vertical asymptote. And that's the only place that I'm excluding here. So domain, all reals, but x cannot equal -1 or negative infinity to -1, -1 to infinity. Range, we said all reals. And the only thing we haven't found yet is the Y-intercept. So back to our graph. If you hit trace, well, it's right there. Trace is popping up on my oblique asymptote. So let's see if I can get the other. I just hit down and it gave me that Y-intercept. You can also always go to your table, and your Y-intercept is where x equals 0. So it's 0, 12. Remember, the blue here is our oblique asymptote. You can double check those roots as well. All right, if you want to talk about those multiple choice questions, watch the next video.